Solar Power Simplified. Greetings, friends. This is Anand Srinivas from Power Mitra, a small firm in Bangalore specializing in small solar power systems for everyday use. Welcome to today's podcast on solar power, where I will try to answer some common questions about small solar power systems. Solar power is one of the unique systems of our times since it's pretty much feasible in most areas of the world and can be set up from a micro scale solar light to large scale solar power plant to power cities. Everyone I talk to gets excited about solar power and its potential to reshape the power scenario in the next few years. But some of the users have had some bad experiences with early generations lights being very dull and unreliable and are very skeptical about solar as a mainline source of power. There are quite a few others who think that solar power can provide cheap power to run anything in their daily life. So let's take a quick look at what today's solar power systems can power and what they may not be very well suited for. Let's start with some basics about solar power generation. Solar power most commonly is generated by PV panels, which are powered by solar radiation and produce a form of current called direct current DC, which can either be used directly for some DC lights and DC appliances, which are not that commonly available, or this direct current is usually converted to alternating current AC by inverters or PCUs or UPS, which is in the form of a current that powers most of our homes from the grid or ESCOM. So once we get AC power, this can generally power our normal household AC lights and appliances. Just a side note, I sometimes get questions like, can I use my solar water heater on my roof to generate the solar power? Answer is no. Solar PV panel is quite different from your rooftop solar water heater, which uses tubes and fins to heat the water. Solar off-grid systems are systems which can be standalone systems that can produce DC or AC power by themselves and power lights and appliances. These systems can only power loads based on their capacity and the type of loads. We'll talk about some typical loads that can run on solar systems a bit later here. Solar on-grid systems are systems which produce AC and are synchronized with the grid or ESCOM power to work in parallel with grid power. The key benefits of solar on-grid system or grid-tied systems are that first, they can export excess power to the grid or draw a portion of the input power from the grid as needed to support their loads. And on-grid systems can run any normal household or commercial loads as they are supported by grid power for handling spikes and surges. Solar on-grid power systems can range from 1 kilowatt to 1000 kilowatt or higher for rooftop solar power applications and much larger megawatt scale for land-based solar plants. There are various technical designs utilized for the on-grid plants, and since it's a vast topic, we will not be able to cover the details of on-grid in this podcast. For the remainder of this podcast, I'm going to talk about off-grid system sizing and components. Now, let's take a quick look at energy storage systems and how they fit in with the solar power systems. Since solar energy is available only for about 8 to 12 hours a day, solar off-grid systems invariably use batteries as a storage device to store excess energy and provide battery power during non-sunshine hours, cloudy conditions, and to cater to some instantaneous high power if solar panel itself cannot meet the needs. So next, what can solar off-grid power systems run? As I mentioned earlier, there are two types of off-grid systems, solar off-grid DC systems and solar off-grid AC systems. First, solar powered off-grid DC systems can run DC lights, DC fans, DC pumps, DC motor-based machines, DC coolers and freezers, depending on the size of the PV panel and batteries. Solar-powered off-grid or hybrid AC systems start with smaller systems of about 0.75 kVA to 2 kVA, which can power regular household lights, fans, computers, small fridge, some kitchen appliances, while medium systems from 3 kVA to 5 kVA can power all single-phase household loads like large fridges, washing machine, air conditioners, water heaters, as well as water pumps, motors, and machines up to 2.5 horsepower. Larger off-grid systems, 10 kVA and above, can power three-phase AC loads like motors, heaters, and machines. When it comes to ease of running some of our normal day-to-day loads on solar off-grid systems, we need to keep in mind that lights, fans, computers, and small printers can run on even small solar inverters. Next comes fridge, washing machine, kitchen appliances, small pumps, which may need medium systems 1.5 kVA to 2.5 kVA to run them. While air conditioner, water heaters, induction stoves, large pumps, laser printers, microwave ovens may need larger systems 3 kVA plus to run them. Solar inverters struggle to handle high motor starting loads and heating loads. So when such loads are to be powered, solar inverter and rest of the system may need to be oversized, which may inflate the system cost to unattractive levels. Some of the solar off-grid or hybrid systems can use grid power as an additional backup when solar power is exhausted, but switch over back to solar power when it again becomes available. Such systems offer flexibility for cost saving and intermittent power situations. Next, let's take a look at how we size solar off-grid power systems. Off-grid solar power systems have three components that affect their size or ability to cater to loads: solar inverters or power control units, capacity, solar battery capacity, and solar PV panel capacity. We will look at sizing each of these three components. Solar inverter PCU or UPS capacity is decided based on which loads need to run at the same time. In other words, how many lights, fans, computer, fridge, pump, etc. need to run. So the kVA or the kilowatt capacity of the inverter is arrived at based on the total load to run. Not all loads may need to run at the same time, and this can help to optimize your inverter size. Solar battery capacity. Amount of electrical units consumed in a day that has to be supported by the solar off-grid systems determines the ampere hour or AH of the battery. If the system can be powered by grid power for some time of the day, this can help to optimize the battery size. While if more than 24 hours of storage is needed to cover for cloudy days and other conditions, higher battery capacity may be needed. Solar panel capacity. Solar panel capacity is also decided by the electrical units consumed per day, as well as the current charging capacity of the solar battery. Lesser panel capacity may lead to lesser solar power than the full day requirements, while too much higher panel capacity will result in unused panel capacity, unless there is a feature to export excess power to grid or other consumers. Some rules of thumb to keep in mind for sizing of solar power systems. Every 1 kilowatt peak solar panel can produce about an average of 3 kilowatt hours, 3 units of electricity per day in off-grid systems. In on-grid, they can produce up to 4 kilowatt average per day. So if your loads consume say 5 to 6 units a day, you may need a 2 kilowatts solar panels and an inverter that can take the 2 kilowatt panel input, maybe 2.5 kilowatt to 3.5 kilowatt inverters. To store 6 kilowatt hour units of electricity per day, you may need battery capacity anywhere from 7.25 to 8 kilowatt hour at about 80% depth of discharge, which would be approximately 600 Ah to 650 Ah of 12 volt batteries. Now 12 volt batteries come in various Ah capacities, with the biggest ones being about 200 Ah each, and one 200 Ah battery can store a maximum of 200 Ah times 12 volts, that's 2400 watt hours or 2.4 kilowatt hours of energy. So this provides you a guidance of the solar panel sizing, battery sizing, and the inverter sizing. What are the types of solar system components? There are different types of solar inverters: PWM, pulse width modulation, MPPT, maximum power point tracking, and others. And different types of batteries: lead acid, lithium ion, and some others. And there are different types of solar panels: polycrystalline and monocrystalline. These come with different price points for some performance and durability premiums, which may be a factor for some applications, but for generic household applications, proven technology and value for money may be a prime factor to go with. Please look forward to our separate podcast with more details on the types of solar PCUs, solar batteries, and solar panels. To conclude this podcast, I want to remind listeners that there is a big world of solar opportunities for decentralized power generation. Apart from the above applications that we touched upon in this podcast, there are exciting opportunities for solar in powering standalone EV charging stations, telecom towers, advertisement hoardings, remote island installations like hotels, unmanned small machineries, and instrument systems. In quite a few applications, solar off-grid systems coupled with suitable energy storage can be a logical, cost-effective alternative to running diesel gensets, especially in remote locations where diesel has to be shipped from long distances. Solar power systems can be our true decentralized and portable power source as long as we understand what it can do and what it cannot. That's all for now. We'll be back with more podcasts on solar power for everyday applications. Meanwhile, please let us know your feedback and any questions on the uses of solar power for home or other uses. You can look us up on Facebook, Instagram with at EcoPowerMitra, that is ECOPOWERMITRA, or check out our website at ecopowermitra.in. Thank you.